One, two, three.
What's up, team? Today we're going to talk about the vertex formula, learning target. I can find the vertex of any quadratic ever using a short formula. So we know that every quadratic is in this form, ax squared plus bx plus c, where a, b, and c are all just some real numbers. A is the real number attached to the x squared, b is the number that's attached to the x, and the c is the constant all by itself. Here's the formula. Make sure to have this written down. This is a big deal. The vertex formula helps us find the x value of the vertex. And we find that by just plugging in negative b over 2a. Well, what the heck does that mean? Where do we get the b? Where do we get the a? Depends on your quadratic. The b is always attached to the x. The a is always attached to the x squared. Let's do an example. We have f of x equals x squared plus 4x minus 5. We know that our a value is 1 because there is a 1 attached to the x squared. We know that our b value is 4 because that's what's attached to the x. For the time being, I don't even care what the c is. It's not a part of the formula. So we know that a formula is negative b over 2 times a. If our b value is 4, negative b is negative 4. 2 times a is 2 times 1. So we have negative 4 over 2, which reduces to negative 2. The x value of our vertex is negative 2. Why does that matter? Well, when we're making our table, as if we're graphing, something we've spent time doing previously, we have to do like our guess and check game. We start at 0, we do negative 1, we do positive 1, and we kind of have to work to get to the 5 points that really matter. Well, if we know the x value of the vertex, we know that the middle point, our turnaround point, is going to have an x value of negative 2. So we'll explore negative 3, negative 4, negative 1, 0. No more guessing, no more checking. We still got to plug these 5 points in, but there's no guessing. We know that it's these 5 points, no more, no less. Let's do another. F of x equals negative x squared plus 4x. Here we have an a value of negative 1, and we have a b value of 4. So negative b over 2a equals negative 4 over 2 times negative 1. It's going to look kind of similar here. Negative 4 is on top. On the bottom, we have negative 2. That reduces to 2. Negative 4 over negative 2. So again, x, f of x. 2 is going to be our turnaround point, the x value of our turnaround point. 1, 0, 3, 4, boom. Then, of course, you plug those x values in to get the f of x values. Last, this one's going to be a little bit sneakier, so stick with me here. A value is 1, b value is 5. Same thing, negative b over 2a. I'm just going to jump right to it. Negative b over 2 times 1. Ooh, this one's weird. So we have negative 5 over 2. So that's going to be negative 2.5 if you put that in your calculator. Negative 5 divided by 2. Weird. We've not had a decimal like this when we've been doing quadratics. It's okay, though. Check this out. What we're going to end up doing is we're going to use that 2.5. Well, it's negative 2.5. Because that's our turnaround point. We don't get to decide whether or not it comes at a whole number. If it's at a decimal, it's at a decimal. So because it's at a 0.5, that's actually quite nice for us. The next points that we'll explore, we'll go negative 3 and negative 4, and then in the other direction, negative 2, negative 1. Still the turnaround point, and we're still going equal distances in the other direction. So we'll get our 5 essential points right here. Okay, vertex formula. I'm really hopeful that this makes your life a little bit easier as you are exploring and graphing quadratics. Okay, let's dive into some practice problems. You got this.